Okay, for this next video, we're going to focus on parallel lines. The first thing I want you to consider is what is that important characteristic about parallel lines that we need to know. And that was that parallel lines have the same slope. You're going to hear me say that 100 times. All right, so again, and we're going to be using this point-intercept form in order to solve our equation. So it says write the equation of a line parallel, same slope, to y equals 5x plus b that goes through point -2, 5. So the -2, 5 is going to represent x1 and y1 in my equation. So that's the point that it has to go through. The reason that I gave you this line right here is because that's what I need. The only thing I need from that, I don't care about the 6, I need the slope. So the slope of this line here in purple is 5 because that's the line, that's the mx plus b, the m is attached to the x. So if the slope is 5 and I want the line of a slope parallel, that means I want the same slope. So the parallel slope would be 5 as well. So now I have everything that I need in order to plug into my formula. Y minus y1, so y1 is 5, so y minus 5 equals m, which is 5, times x minus, and I'm going to put parentheses here because I have a -2. Okay, so the y stays by itself, the x stays by itself. The only things that you actually substitute things in for is y1, m, and x1. So you just have to determine what is that y1, what is that x1, what is that m. Okay, from this equation, we just need to solve for y. So y minus 5 equals, and I'm going to just simplify this inside parentheses first. So if I have a minus and negative, that becomes x plus 2. From here, I'm going to distribute that 5 using that distributive property. Distributive means multiplying, so 5 times x is 5x, 5 times 2 is 10. Okay, is y by itself? No. So add 5 to both sides, and this is the actual answer we're looking for. This is the equation of a line. It's parallel to the line that was given to us, and it also goes through the point that we were asked for it to go through. All right, so for this next one, I gave it a little bit different format. I don't really like this format because it doesn't tell me what the slope is. So the first thing that you want to do is you want to make sure that you always start by solving for y. So y minus 2x equals 8. All I have to do is add the 2x over, and y will be by itself. So y equals 2x plus 8. So what is the slope of this line? The slope is 2. It's always the one attached to the x. Okay. Also, it gives us a point. Again, that point represents x1 and y1. So once I've identified x1, y1, and my new slope, so parallel slope means same slope, so same slope to 2 would be 2, and then I can go ahead and plug into my formula. So y minus y1 equals m times x minus x1, and I probably should have wrote this in the formula above because then you could have seen I'm plugging in to y1, m, and x1. So from here, substituting those values in, so y minus, I've got another negative, so I'm going to put that in parentheses. M is 2, that's my new slope, and then x minus 5, and then I just have to simplify this equation. Y plus 6 equals 2 times x minus 5, and then I'm going to bring it up here. I'm going to change colors too because there's a lot of red around here. We like red here at Central, but not too much red. All right, so y plus 6 equals 2. I'm going to distribute that 2. Y plus 6 equals 2x minus 10. Again, get y by itself by subtracting over. I have y equals 2x minus 16. So this is my solution. Notice again that the slope of the original line, which I solved for over here, and the slope of my new line have the same slope. And ask yourself, why do they have the same slope? Because they are parallel lines. Okay, so let's look at another example. This is a little bit different. It's giving me 2 points, and then it's giving me a third point that it has to go through. So I've got a line that goes through 2 points, and I'm kind of just going to graph this real quick to give you an example of what it looks like. So we've got 2, 0, that's L, and 5, -6. 1, 2, 3, 4, 5, -6. So my line, which is hard to draw, looks something like this if I can go through the points there. All right, and I want to find what that slope of that line is. And then I want to find out an equation of a line that goes through -2, -3. So I'm ultimately trying to find this blue line, and that's supposed to be parallel. So the first thing that you have to do when you're given 2 points is you have to find the slope. Well, we talked about the slope in an earlier video. y2 minus y1 over x2 minus x1 equals m. Again, I only need 3 things when I'm plugging in and solving. I need y1, m, and x1. So plugging in what I know, I'm just going to choose one of these to be x1, y1, and one to be x2, y2. And the x1, y1 in this case is different. So this is the x1, y1 for my slope formula because I'm trying to solve the slope. But when I get to my point slope formula, I'm actually using this point because that's the point I needed to go through. So that's going to be -6 minus 0 over 5 minus 2. That gives me -6 over 3, which is -2. So the slope of the red line is -2. And because parallel lines have the same slope, that also means the slope of the blue line, my new point, is going to be also -2. All right, so I have my slope that I need, and I also have the points x1, y1 that are going to go into my formula. So, and I have the slope, so I can just go ahead and start plugging in. So y minus y1 equals m times x minus x1. I've got y minus a -3 equals -2 times x minus a -2, lots of negatives all around. So y plus 3 equals -2, x plus 2. Distribute that -2, so y plus 3 equals -2x minus 4. Subtract the 3 over, and you're left with y equals -2x minus 7. And that -2x minus 7, that is my blue line, which is what I was trying to solve for. Okay, and just one other type of representation is I can give you a graph. So if I give you a graph, again, the first thing you have to do is you have to solve for the slope. I also want the line through a point, so I know that it's going to automatically look something that looks, if I can hit that C, like that. So this point right here, that 4, -2, that's going to be the x1, y1 that I plug into my formula all the way up here at the top. But I need the slope of this equation of the line. And I can do that either by doing the y2 minus y1 over x2 minus x1 and use points A and B. Or another way, so maybe you try that on your own, but another way is to just count the rise over the run. So I'm going to count 1, 2, 3. So my rise is 3. 1, 2, 3, 4, 5, 6. My run is 6. So your slope is rise over run, which is 3 over 6, which is 1/2. So the slope is 1/2, and the slope of a line parallel has to be the same slope, so that would be 1/2 as well. So now I've got all the stuff that I need in order to plug in to my equation up here. And I'm just going to solve this real quick. So y minus -2, that comes from the point that we wanted the line to go through, equals 1/2 times x minus 4. Sometimes fractions can look scary, but I promise they're not. So y plus 2, I'm simplifying the negatives. 1/2, and I'm going to keep it just the same. I'm only going to do one step at a time. Distribute the 1/2. So y plus 2 equals 1/2 x minus 2. Subtract 2 from the left. I have to do the same thing on the right. So y equals 1/2 x minus 4. So again, notice that these slopes, the slope of my new line, my answer, and the slope of the original all are the same, and that's what makes a parallel line.